What is the theory of evolution in geology? The theory of evolution in geology is a central concept in the study of the history and diversity of life on Earth. This theory posits that all life on our planet shares a common ancestor, and that over time, living organisms have changed and diversified in response to changing environmental conditions. Geologists use various methods to study the evolution of life on Earth. One of the primary methods is the analysis of fossils, which are the remains or traces of ancient organisms that have been preserved in rocks or sediment. By examining the characteristics of different fossils and comparing them to living organisms, scientists can infer how ancient species may have looked, behaved, and evolved over time. Geologists also study the geological history of different regions to understand how environmental conditions have changed over time, and how these changes may have influenced the evolution of different species. For example, by examining the layers of sediment in rock formations, geologists can reconstruct the history of past climates and ecosystems, and how these may have affected the distribution and diversity of different organisms. In addition to these methods, scientists also use genetic analysis to trace the evolutionary relationships between different species. By examining the DNA sequences of living organisms and comparing them to each other, scientists can construct phylogenetic trees that show the evolutionary relationships between different groups of organisms. These trees can provide insight into the history of life on Earth, including the timing and order of major evolutionary events. The theory of evolution in geology has numerous practical applications, particularly in fields such as medicine and agriculture. By understanding how different species have evolved and adapted over time, scientists can develop new treatments for diseases, improve crop yields, and address other challenges related to the health and well-being of humans and other living organisms. Overall, the theory of evolution in geology is a powerful tool for understanding the history and diversity of life on our planet, and for developing practical solutions to some of the biggest challenges facing humanity today. How did geology contribute to the theory of evolution? Geology has played a crucial role in the development and refinement of the theory of evolution. Here are some ways in which geology has contributed to the theory of evolution. Fossil evidence. Geology provides the main source of evidence for the history of life on Earth through the study of fossils. Fossils are the remains or traces of ancient organisms that have been preserved in rocks or sediment. By examining the characteristics of different fossils and comparing them to living organisms, scientists can infer how ancient species may have looked, behaved, and evolved over time. The study of fossils has provided a wealth of evidence to support the theory of evolution, demonstrating that living organisms have changed and diversified over millions of years. Stratigraphy. Geology provides a way to determine the relative ages of different rock formations through a method called stratigraphy. By studying the sequence of rock layers in a particular region, geologists can determine the order in which different rock layers were deposited, and hence the relative ages of the fossils found in each layer. This provides a way to construct a timeline of the history of life on Earth, and to track the changes in the fossil record over time. Plate tectonics. Geology provides a framework for understanding how the physical and environmental conditions of the Earth have changed over time. The theory of plate tectonics, which explains how the Earth's crust is composed of large plates that move and interact with each other, has played a particularly important role in this regard. Plate tectonics has helped to explain the distribution of fossils and the diversity of life on Earth, as well as the role of major geological events, such as volcanic eruptions, earthquakes, and climate change, in driving the evolution of different species. Geographical isolation. Geology provides a mechanism for the process of speciation, or the formation of new species. Geographical isolation, or the physical separation of populations of organisms by barriers such as mountains, rivers, or oceans, is a key factor in the process of speciation. Geology plays a role in determining the location and nature of these barriers, and in understanding how they have changed over time. Overall, geology has contributed to the theory of evolution in a variety of ways, providing evidence, context, and mechanisms for the process of evolution. Through the study of fossils, stratigraphy, plate tectonics, and geographical isolation, geology has helped to build a comprehensive picture of the history and diversity of life on Earth. Please don't forget to subscribe to my channel and turn on notifications.